limestone, and the fact that I was able to do that tells you that it's limestone. This is a mini cave, a little tiny cave. This is formed by natural solution of a quite pure limestone. Now the last limestone we saw, the only other limestone we saw, was in that quarry just before we ate. That was a very dirty limestone. The only way you could tell it's limestone is because I put the acid on it and watched it fizz. But it's full of clay and silt, and you could just as well call it a siltstone or a clay shale with a lot of lime in it. This one, there's no question. This is a pure limestone. This is what's called Middle Cambrian, beginning of the Paleozoic, when there were no mountains around here anywhere. And this was a shallow ocean. The best analogy you could find to it today is the ocean between northern Australia and New Guinea. New Guinea is really part of Australia, except that the continent there is so low-lying that the ocean has flooded in over it. It's really continental crust. That was the same here 500 million years ago. So this is good continental crust, but it's shallow, very shallow water, very much like Florida Bay today, with a lime mud, very fine-grained calcite, and in shallow water. Of course, if you want me to prove that it is limestone, I came prepared for that. You got a piece there. We can. I'm fine. That was on purpose. I didn't slip. Oh yeah. Yeah. So that's obviously limestone. And the lowermost Paleozoic is all very much like this, because there were no hills, no mountains nearby, a very shallow water, and it's actually full of fossils, except the fossils here are mostly broken up and very small. So in this particular rock I've never been able to see any, but there are fossils in it. Now the rock a little bit below is yellowish. Let's see if that...
He's got a pace. Dennis, the student has a yellow rock.
Yeah, don't eat off yellow rock. Yeah, this might do it. It's fizzing a little bit there. That's calcite in there. But the rest of this rock is more dolomitic. There are dolomite beds in this rock. And that tells you a couple of things. First, it confirms that it's marine, because dolomite is a marine rock. Second, if you remember how dolomite forms, the few people that got that question right in the test, you take calcite rock, limestone, and you put a strong brine on it, very, very salty water, and the magnesium replaces calcium carbonate, which is dolomite. And that happens when you have A, shallow water, and B, a hot, dry climate. Okay, well, this does not qualify as a hot, dry climate here. This is a rather damp climate, and it's not especially hot, aside from the fact that it's not marine. Back when this rock was deposited, this part of the world was in the southern hemisphere, in the tropics, in the desert zone, equivalent to, let's see, Central America, say. And you've got water constant in the shallow water. You've got the water evaporating, not being replaced by much rain, like the Red Sea today, which is very hot, very warm, and very salty. And so that's where you get dolomite forming. Now, as to the holes in the rock. If you take slightly acid rain, that's rain that's fallen through the atmosphere and takes carbon dioxide out of the atmosphere, forms a weak solution of carbonic acid. We can be grateful for that, by the way, because that's why we don't have a carbon dioxide atmosphere like Mars on the one side of us and Venus on the other side. If you've got liquid water, the rain pulls the carbon dioxide out of the air. Now, if you take carbonic acid and react it with calcium carbonate, you make calcium bicarbonate, which dissolves. So in slightly acid rainwater, you get caves in limestone. So just looking at that, I could have said it's a limestone because it's been dissolved. That's not something that somebody drilled there. That's a completely natural hole developed in it. There are some commercial caves around here as well, but that is a small cave there, right itself. Some caves get a little bit bigger, by the way. I think in Mammoth Cave National Park in Kentucky used to have the biggest cave, the longest cave in the world, and the third longest cave in the world. And the third longest cave was Mammoth Cave. Okay, now it just has the longest because they took the longest and the third longest and found a passage connecting them. So now it's by far the longest cave in the world. I think it's up to 400 miles of cave. Now, a good deal of that cave is not really very accessible. As a matter of fact, some of it isn't accessible at all. The reason it took so long to connect them is because the passage connecting them is actually below the water table. So unless you've got gills or are very good at wiggling through very, very tight spaces under a few feet of water, you can't go through it. They did it, they found that only during a severe drought when the water level dropped down. And at that, when they went through the final passage, they had to do it on their backs so their nose would be up at the top of the passage and they could breathe. Interestingly enough, after they did this, just a short distance away, they went in the longest cave in the world, and when they passed through that and climbed up a little bit, they ended up in a tourist passage in Mammoth Cave. So you had the tourists coming by, watching these mud-drenched, bedraggled people crawling out of a hole in the ground, which must have been interesting, because they had been in there for over a full day, crawling through these little tiny passages. They were a mess. Anyway, same thing is true here. This, by the way, is called karst topography, K-A-R-S-T. Karst topography is topography that's been influenced by solution, by dissolving. You can see where cracks in the rock have been enlarged by water trickling.
That's when you can see the crack of the,
Well, no, I
like
haven't.
the ledge of the sandstone and the shale before. Can you tell where?
That's shaly dolomite underneath. By the way, why is it yellow? It turns out that iron is smaller than calcium and doesn't fit that well into the calcium structure because it's just a little bit too small. Calcium's a big whopping atom comparatively. Magnesium is a very small one. So calcium carbonate doesn't take that much iron in it, and when it weathers, it weathers gray. The dolomitic rock, though, since it has a layer of magnesium atoms, the iron can go in there more easily. So dolomite tends to contain a little bit of iron in it. When it weathers, it's yellowish because of the basically rust. Gritite, in this case, gritite has a more yellowish color than hematite. This whole, I talked about this before, since we're now in the Great Valley. The Great Valley is a limestone, very heavily limestone section at the bottom of the Paleozoic. And it runs all the way from Quebec down into Alabama. East of it is the Blue Ridge, and the Blue Ridge could just as well be called part of the Valley and Ridge province, because all it is the biggest of the anticline, the biggest of the upfolds that has carried up the oldest rock, the Precambrian rock, including the granite and the lava, what's called Coskren Greenstone. As I say, both the granite gneiss records the assembly of rodinia. The greenstone, the Coskren metamorphosed basalt, is a flood basalt recording the breaking apart of rodinia and the formation of a rift there. South America went one way, North America went the other. And then the folding of this whole area later on is a result of the assembly of Pangea. The collision of Africa did the folding. And there's a rift valley over in Frederick. You get to see that maybe on the spring trip. And that rift valley is one of the rift valleys associated with the pulling apart of Pangea into North and South America and the opening of the present-day Atlantic. So this is a repeat of what I told you in the geology of Maryland. So if you don't get that right, when I put it on a test next time, you have no excuse. Yeah, you've seen some of the evidence, and if you come on the spring trip, you'll see the evidence in the Blue Ridge for the assembly and disassembly of the two supercontinents. Okay? That's it.
All right.
Cracks and shatters, you get solutions trickling through those cracks, depositing pure calcite, which is the white. So if I put acid on those white streams, they too would fizz beautifully. Now a little bit further to the east in the greenstone, you also have white veins running through it, except those veins are dark. Way still higher. Why, of course, you took the mineral lab. That's how you tell them apart. The minerals you did get in the mineral lab are, of course, all the commonest ones.